All right, here we go. So the title of this thing is called Solving Inequalities. Girls, thank you. It's called Solving Inequalities. So what have we been doing so far? We haven't been doing inequalities. What have we been solving for? You got an equal sign, so it's an equality, right? So these are inequalities. You probably know this already without even looking at the book. Give me an example of an inequality. If it's not equal to, it could be what? Greater than or less than, right? Or greater than or equal to or less than or equal to. But that's what we're talking about when we're talking about inequalities. Today's lesson is not really like a lot of math, okay? It's basically just to show you notation, all right? To show you, it's basically teaching you the language of inequalities, all right? How to write inequalities. That's basically all it is today. So it's pretty simple. It's not too difficult. It's stuff that you probably had for several years before today. So we're going to go through it. I'll try to go through as quick as I can. All right, let's take a look at the first one. So if I have, oops, I forgot to do this. Turn that to that. Let's turn that to that. Let's change that. Does that work? Yeah, there we go. Now we're good. So let's try that again. So what if I had this? Actually, let's go in the order that I did it in my notes. So if you have this, you have A, what's that little symbol right there mean? Anybody know? That's less than. Okay, so that little symbol means less than. Thank you. Let me just show you real quick how you can remember. When you're a little kid, what did your teacher... Whoa, what was that? What's going on over there? Better turn it off. Yeah. So you got this thing called less than. So where did this thing come from? When you're a little kid, your teacher probably taught you a way. Do you remember, did your teacher teach about like an alligator or something that's eating the bigger one? Is that what they're doing? Okay. I never taught that. I never taught little kids. So you can do that. It kind of looks like an L for less, but here's basically what it is. Watch. It's basically, let's see if I can draw this a little straighter. So watch this. Everybody see this? What's that symbol right there? That's an equal sign, all right? So what if you did this to it? Boom, boom, boom. Do you see how those two parts came together and got closer? They got smaller, right? They got less than. Do you see it? Because you had a space like this, and then those two ends came together and they became smaller, so they became less than. Would you agree? So the distance between these two lines now is less than it was before when it was an equal sign. Would you agree? What about the distance between these two? They got what? They got greater. So this side means greater. This side right here means less than. Everybody see it? So the pointy end is the less than, and the end over here, or the alligator that's eating the bigger number, okay, if you want to think of it that way, that's the greater side. A lot of people still want to stick with that. It's perfectly fine. But that's where you get the less than or greater than. It's from an equal sign, and you take that equal sign and you just kind of bend it. All right, you bend it towards the smaller one. So this is less than. So if I read from left to right, which we do in the English language, all right, if you go from left to right, this is A is less than B. Everybody got that? All right, so let's write that down. A is less than B. All right, so let's do another one. What if we did this? I told you this was easy today, didn't I? It's not much different than this, the whole lesson, really. What if we had A is what? What's this one? This is greater than. So it's A is greater than B. Remember, these represent numbers. It means the number A, this is bigger than B. Give me an example with some real numbers in here. Give me a real number for A and B that makes this thing true. Okay, 5 and 4. So A is 5, B is 4. Does that work? Is 5 greater than 4? Absolutely. Give me something for A and B, different numbers for the A is less than B. 2 and 7. So if you put a 2 right here for A and a 7 for B, 2 is less than 7, and that works. Okay? Everybody with me so far? Yeah, pretty basic. So you also had this. you had this A is less than B. I'll tell you what, I'm going to do this underneath it here. And let's do it in a different color, might as well. All right, so what if we had this? A is less than, what's that little thing right there? What's that do? What's that mean, Justin? Yeah, it means this means less than or equal to B. So A is less than, so let's write this here. A is less than or equal to B. Give me an example that we could put for some numbers here. Matt, give me a number that works for A and B here. Sure. Give me something here. 4 and 4. Okay, that works, doesn't it? All right, because 4 is less than what? Or equal to B. So if I put a 4 here and a 4 here, that could make this thing true, couldn't it? All right. Now, you could also put a smaller number for A and a bigger number for B. That would work as well. But you could put two numbers that are the same here. I'm glad you said that because that's what I wanted you to say, actually, is the equal part of that. All right. What about this? Let's finish it. It's pretty easy. Instead of A is just greater than B, it's what? A is, I don't even know why I'm writing all this out, but I'm doing it. So A is greater than, I'll come down here, or equal to B. All right? So that's what we got so far. Pretty simple stuff. Wouldn't you agree? Yeah, you've been doing this since you were a little kid. In elementary school, they probably did less than or equal, or less than or greater than, didn't they? Yeah, I think so. I don't know. It's been a long time since I've been in elementary school, and I've never taught it. So here's another one that's a little bit weird. We're going to be doing stuff with this. We're going to be doing a lot of this kind of stuff right here. All right? What does this mean about A? Or about X, I'm sorry. So X represents a number. So X could be two things, right? So what do we got? X could be greater than A. Because watch, if you read this from right to left, everybody watching me? If I read this from right to left, if I went this way and I wanted to compare it to the A, X would be what? If this would be greater than, if I'm going from right to left, okay? But you're probably thinking, Mr. Hamrick, you said this was less than earlier. Yeah, it depends which direction you're going, right? If I'm going from left to right, this would be A is less than X. If I'm going from right to left, this would be X is what? Greater than A. You with me? So X is a number that's bigger than A, that's greater than A, and it's also what? Less than B. So that means X must be somewhere in between. Exactly right. So this must mean that X is somewhere between these two numbers right here. So let's put two numbers here. Let's put a 2 and a 7. All right? We'll put an X right here. Give me some possible. Now look, there's a ton of different answers. In fact, there's an infinite number of answers for X. All right? But what does this mean right here? It means X is a number that's between 2 and 7. Could it also equal 2 or also equal 7? No, because it doesn't have an or equal sign here. If I put an or equal thing right there, sure, it could be equal to 2 or it could be equal to 7. But there's no or equals here, so X must be some number between 2 and 7. Somebody give me a possible solution for X. What could be a number between 2 and 7? 4, 5. Give me something else. 6. Give me some other things. You're being too easy. You're just giving me integers. What is it? 2.5. That's right. 2.5 is between 2 and 7, isn't it? You with me on that? So you could have fractions. You could have decimals. That's why I said that there's a, what did I say the number was? An infinite number of possibilities for this, right? Because you could say 2.00001. Would that be between those two? Yeah, absolutely. All right. Notice, when X is between these two, look which direction. This is the way that we always write it. When I say the number is in between two other numbers, this is how we write it. We write 2 is less than X, which is less than 7. These are always the less than. What if I wanted to make this, but I wanted to say greater than? How could you do that? What would I put here? Would I put a 2 here? Okay, you put a 7 here and a 2 here. You could write this. This right here, this stuff right here, is the same exact thing. Would you agree? Because this means x is a number that's less than 7, and it's a number that's greater than 2. Isn't that what's that saying right there? Yeah, it is. But we don't write it like this normally. You could. It's not wrong, but you don't write it like this normally. This is how you would write something like this. Make sure you watch the end of the video. Okay, so make sure that you write it like this. Put the smaller number first, the bigger number last, okay, and then the x goes in the middle. These should be less than. Everybody got that? Okay, because a lot of people mix it up and put it greater than or whatever. You don't want a combination either. So, for instance, this right here. I'll put an or equals in here just for fun. What about this? They're both less than, right? Less than or equal, but they're both less than. Is this okay? Give me a number that works for this. Give me a number that's bigger than 2 and is also, what? Less than 1. Is there anything like that? So look, here's 1. Let's go to a number line because we're going to be doing number lines here in a little bit. Okay? So think of a number that's bigger than 2. So where are all the numbers bigger than 2? Right, they're to the right of it, aren't they? Okay, and then also give me a number that's less than 1. It would be all these. Is there a number that satisfies both of these things? No, there's not. You cannot have a number that's bigger than 2 and also at the same time less than 1, can you? No. Like right here, how would I draw the number line with this? Put the little arrows here. What would I put here? A 2 here and a 7 here. How would I graph this thing? All the numbers between 2 and 7. What would I do with that? No, not dots. Oh, okay, I see what you're saying. But we're just going to color that in, right? Now, it's not between, or it's not equal to 2, and it's not equal to 7. So back in the old days, we'd put a little circle there, open circle, wouldn't we? Remember that? Okay, and then you color everything in between. So anything in here will satisfy this inequality. But right here, there's not one number that satisfies this inequality. All right, so you always want your smaller number to the left and your bigger number to the right. Everybody got it? Okay. Yeah, that's that. Let's move on. So what we're going to do, we kind of hinted about this just a second ago. Remember, oops, watch. This is less than or equal to. So what would we do with this circle if it's or equal to? Do you remember this? Yeah, you color it in, okay? Shade it in. Remember that? And then you'd shade that in. So that means it could equal 2. Agree? This one right here, if it's open, it means it could not equal 2 and it could not equal 7. But this could equal 1 and it could equal 2. That's kind of like the middle school, high school version of graphing. This is called college algebra, so we're going to do it a little bit different. So when you get to the upper levels, they don't do that open circle, closed circle thing. They do this thing, and it's called interval notation. So let's do this. All right, so x is some number between a and b, between whatever those two numbers were. If we were to graph this, I'm going to tell you what, I'm going to graph it over here. If we were to graph this, what two numbers are on my number line here? It's not 2 and 7 this time. What is it? It's a and b. And x lies somewhere where? In between, right? A and b. And it could also include a, and it could also include b. Would you agree with that? All right. So normally, what we just finished doing, we would put a closed circle here. Remember that? Okay, we put a closed circle here, but we're not going to do that anymore. What they do, instead of a closed circle, here's your new notation. You may have seen this before, I don't know. But if you haven't, we put a bracket. That means the same thing as closing the circle, okay? It just means the same exact thing. It's just a different look. It's a different way to look at it. And then we still color everything in. Okay, make that a little bit thicker so you can see everything in between here. So this means this. We got it? It's not much different, right? It's the same kind of thing that we did before, except instead of a closed circle, we put a bracket. Everybody good with that? There's another way to write this. Instead of writing the whole graph like this, we call this stuff interval notation. And they're going to ask you to write some of your answers in interval notation. All right, and here it is. And it's very similar to this graph. The reason I drew the graph is because of this. What we're going to do is we're going to put A, comma, B. This is not an ordered pair. This is not, going over to the right on the graph and going up or down or anything like that. This is interval notation. But you have to say whether it's less than or equal to or just less than. Okay, so what is this one? It's or equal to, so we put a bracket here and a bracket here. All three of these things indicate the same exact thing. Everybody see that? So this is a little bit new probably. That'd be my guess, isn't it? That's probably a little bit new for you. But this is how we write this. So this means the exact same thing as this, and it means the exact same thing as that. This is a little shorter. It's a little more compact. So it's a little bit nicer. Like mathematicians like it a little bit better than this because it's just a little more compact, a little easier to write. All right, but you got to know what you're talking about. So that's not too bad, is it? So let's do some more. Let's do one without the or equal to. So what if we had this? So our interval notation, we're going to have our A, comma, B, but instead of a bracket, the way that we show an open circle, right, instead of a closed circle, is we just put a parentheses. All right? So the parentheses means open, and the brackets means that it's closed. All right? Just like we would have had a closed circle or an open circle, that's what that means. Everybody got that? So if you were to graph it, how do we graph it? You'd put A right here, put a B right here, and it's not or equal to, so what kind of a thing do we put on our graph here? Not an open circle anymore. Now we're big kids, okay? We're in college algebra now, all right? So now we just put a bracket. We don't put an open circle, we just put a bracket, and then you still fill in, still kind of darken in the stuff in between. You with me on that? That's not so bad, is it? Nah, it's just a different way of looking at it. That's all that is. All right? You could have some that are half open and half closed. So let's take a look at this. What if you had this? That's supposed to be a less than symbol right there. Okay? So what if you had this? How do you think you would write this in interval notation? Well, you'd put the A, comma, B, right? So if this is just less than, it's not equal to, what are we going to put over here? A parentheses, that's right, because it's not equal to. But this one over here on the right is or equal to, so what are we going to put over here? A bracket. Simple. You agree? And it's a little less writing, isn't it, than putting all that less than equal stuff, and you don't even have to put an X in there. This just means there's some number between A and B. It could be equal to B, but it's definitely not equal to A, all right? But it's in between there somewhere. And of course, we could do it like this. This is no different. All right, what if we had this? Again, you put your A, comma, B. Now you got to figure out if is it a bracket or is it a parentheses? What's the left side going to be? A bracket, good. And what's the right side going to be? A parentheses. So this one's open, this one's closed. You got it? Yeah, piece of cake. So those are called half open or half closed. All right, you have something else. Like what if I had this? What if I had x is greater than 3? How would I graph that? Well, put it right here. Put a 3, or it's going greater, so I'm going to go bigger. So I'm going to go 3, 4, 5 on my little graph, put little arrows on the ends. So how would I graph this back in the day? When I was in Algebra 1, Algebra 2 stuff, how would I graph this? I would put an open circle at 3, wouldn't I? But now in college algebra, we're not putting an open circle. What are we putting? A parentheses. And it's greater than 3. Is it in between anything? No, it keeps on going, doesn't it? It keeps on going where? How far? Infinitely. That's the word I wanted to hear. It goes infinitely. It goes to infinity. Is there an actual spot where you can reach infinity? No. You know the, what's that dude on Toy Story? Buzz Lightyear, to infinity and what? Beyond. Can you really go beyond infinity? No, because infinity itself is already beyond. You follow me on that? So you can't go infinity and beyond because you can never get to infinity anyway, all right? Infinity and beyond kind of makes an assumption like you can get to infinity, but you can go a little bit further. Nope, you can't. So anyway, there you go. So that's how you would graph this. How would you put this in interval notation, though? Okay, so this is a little bit different.
When the bell rings, when Megan Inglis, Michaela Fowler, and Josh Stoll please come to office. Thank you.
Why are they doing that so early? It's not over till 10:45. Okay, so what if we did this? Let's put this in interval notation. So we don't have an A and B. We don't have two numbers, but we start at 3, and where are we going? We're going to where? Infinity, right? So what are we going to do? We're going to put infinity. Do you know how to write infinity? You should know this. Yeah, it's like a sideways 8. Okay, I'm always terrible at writing those. That was actually pretty good. So this is greater than 3. So what kind of a thing do we have? Is it open or closed? It's open. So we put what at the 3? Parentheses. Now what about infinity? Is infinity closed or is it open? What do you think? Can you ever get to infinity? So is it open or closed? What? It's open, right? It's open, all right? Infinity is always going to be open because you can never get there, all right? You can never arrive at infinity. You with me on that? So anytime you have an infinity, it's always going to be open. We got that? So that's how you would write this in notation, in interval notation form. This is how you graph it nowadays. So from now on, this is how we're graphing. You will have some problems where they're going to ask you to graph. This is how you're going to have to graph it with the open and closed stuff, all right, with the parentheses and the bracket. So, get used to that and get used to this interval notation thing as well. We good? All right. Let's just do a couple things. What did I say, 45? Yeah, we got plenty of time. So let's go ahead and finish this part up right here. So x is greater than or equal to a. So here's the old-fashioned notation that we would normally do. So what's the new way? What's the interval notation? So x is some number that's greater than a. So it's greater than a. So what's my number? It's a, isn't it? How do I show that it's greater than this? It's got to go to the right, correct? So the a should be on the left, so you put a comma, and then if it's greater, how far does it go? It goes to infinity. Okay, it's greater than or equal to, so what do we put here at the a? Bracket. What do we put at the infinity? It's always parentheses at the infinity. You got that? Okay. Let's do another one. Whoops. This is kind of the same thing, except what? So it's greater, so I put the a first, and then I put infinity second. What kind of symbol is going to be at the a? Parentheses, because it's open, right? It's not or equal to. And then again, infinity is always open, so no need to even worry about that. What about this? We're changing it up a little bit. X is less than or equal to a. So you got the a, but do you put a comma infinity? No, because it's less than a, so we're going to keep going to the left. So where is infinity this time? It's to the left, isn't it? I don't know if you've seen this before. You probably have. But if it's to the left, if it's smaller than my number, to the left is negative infinity. All right, so you can have a negative infinity and a positive infinity. All right, so if it's going to the left, it's negative infinity. So infinity, does it ever get there? No. So it's not closed, it's what? It's open. What about the a? Can it get to the a? Sure it can, because it's or equal to. So what do we put at the a? Put it bracket. That's how you'd write, kind of got it a little squished a little close. There we go. Okay, so that is how you write this in interval notation. And if you were to graph it, I didn't do the graph, but let's do the graph on the first one. So if A is right here, where's it going? Is it going to the left or to the right? It's going to the right as far as we can go, so we just darken the arrow. So that's how we would, oh, we need something else here. We need a bracket. So that's how we would graph this. You with me? So you got to be able to take this, turn it into interval notation, and you'll also need to be able to graph it. All right? What about this one right here? How do we graph this? Well, we start at A. Which way do we go now? We're going less than A, so we're going to the left, aren't we? So we squiggle, 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 darken it in, whatever you want to do, and then darken in the arrow. What kind of bracket do we, or what kind of notation do we have at the A? This is bracket right here. What about this one? This would be the same thing as the first one, except what? Parentheses, all right? Darken that in. There we go. So that's how you graph these things. So it looks a little different than what you're used to, right? Especially with that interval notation. That's the biggest new thing. And the graphing's pretty much like we did before, except an open circle. Instead of open circle, it's a parentheses. Instead of a closed circle, it's a bracket. All right? We don't need to do the less than, right? You can kind of figure that out. But here's another one. What if you had this? What if it said all the real numbers? That includes fractions, decimals, okay? All the real numbers. Even includes stuff like pi or the square root of 2, okay? They're real numbers as well. They're irrational numbers, but they're still real numbers. So how would I graph all the real numbers? Here's the graph. What if I wanted to graph every single number? What would I do to that graph? I'd color in what? The whole entire graph. Going to the right and what? Going to the left. Would you agree? That means it goes all the way to where? Positive infinity, and it goes all the way to negative infinity. So how would I write that in interval notation? Yep, parentheses, negative infinity, comma, positive infinity. That's right. So if I wrote all the real numbers, this is how I would write it in interval notation. This is how I'd graph it. We good? Let me see your pen. Yeah, here you go. Here's your pencil. All right. Let's see what else we got. Okay, let's do some examples. This is kind of stuff they're going to ask you to do on the homework, so I'm tired of that yellow. Let's change to a different color. How about this pink, hot pink? So it says, write each inequality in interval notation. So let's write that down. This is an example. This is kind of stuff that you're going to be doing on your homeworks tonight. Okay, and it should be very easy. Write each inequality using interval notation. Using interval notation. That's the thing with the brackets and the parentheses and the comma and all that stuff, okay? That's what we're doing. So this is example 1, and this is A. So here it goes. 1 is less than or equal to x, which is less than or equal to 3. You're taking notes, aren't you? Write this down in your notes. Write this thing right here, and then write down what the interval notation is going to be. I'll do a few more, and then you can write them down and figure out what it's going to be. This is what we've been doing the whole time, just changing this to interval notation. And can I squeeze D in right here? It's probably off the screen, isn't it? Is it still on the screen? Oh, good. Whoops. Oh, there it goes again. Why does it do that? I don't know. There it goes. What did I say this was? 1? Okay. All right, there you go. Have you done them yet? So look at this one right here, interval notation. Well, what are your two numbers on the ends? That's the easy part. 1 and what? 3. So you put a 1 comma 3. That's easy, right? The only thing really you have to think about is, do you put a bracket or put a parentheses? So what do you put on both of these? Brackets. Did you guys get that on your own? Yeah, simple. I told you it was simple, right? I'm not lying to you. What about this one? Put a negative 4 comma 0. Now, what's going to go on the outside of here? Both parentheses, right? Because you don't have an or equal. The reason we put a bracket is because both of them had or equal. What about this one? C. X is greater than 5. Now we don't have two numbers, but we got to figure out what's bigger than 5. So you're going to put 5 first, right? Comma, what? Infinity. That's right. Okay, because if it's bigger than 5, 5 has to be at the beginning, right, on the left, and then it goes all the way through infinity, so you got to put that there. What kind of symbols do we put here? Parentheses on both of them, okay? Remember, every time you see an infinity, it's always a parentheses, all right? The only thing we had to look at was right here. This was not or equal to, so I put a bracket, or I put a parentheses right there. All right, let's do this one. X is less than or equal to 1. So we're going less than 1, so 1's going to be on the right, and then what's going to be on the left? Negative infinity. Don't just put infinity, put negative infinity, because it means it's going to the left. That's what the negative sign indicates. Infinity is always a parentheses. What about the 1? It's a bracket because it's or equal to. My goodness, this is way too easy, isn't it? Guess what they're going to do now? They asked you to go from an inequality to interval notation. What do you think they're going to do now? Go from what? Example 2. They're going to go the other way. They're going to give you interval notation, and they want you to write it as a inequality. All right? So let's take a look. So this is 1, 4, bracket, parentheses. That's A. B is 2, comma, infinity, parentheses with both of those. Part C is 2, 3, brackets. And then part D is negative infinity to negative 3, bracket, parentheses. So now we're doing the opposite. Okay, instead of going from an inequality to an interval notation, we're starting with interval notation, and we want to make it look like this inequality. All right, let's change colors. Oops, I didn't change it. There it goes. All right, so what do you think? Well, it's between 1 and 4, right? So I'm going to put an X here, I'm going to put a 1 here, I'm going to put a 4 here. Now we just got to figure out what the symbol is. It's always less than, right? We always put less than. But there's a bracket here, so this is going to be not just less than, it's going to be what? Less than or equal to. See that? This is open right here, so this is just going to be less than. Simple as that. No math involved, right? You just have to know which number is bigger and smaller. That's all you got to know. That was easy. What about this one? Well, this means it's everything from 2 all the way to infinity. So that means it's going to go what? Is that going to be less than or is it going to be greater than? This one right here. 2 starts on the left, right? And it keeps on going to the right. So X must be greater, right? X must be greater than what? 2. Do we put an or equal here? No, because of the parentheses. With me? Okay, this is kind of like A. So you got a 2 and a 3. Put X in the middle. These are brackets. So this is going to be not just less than, but less than or equal. And this is also going to be less than or equal. Pretty simple. What about this? Which direction is this graph going? Picture this graph in your head. It's going to the left, isn't it? So it's going to be what? To negative 3. X is less than. You see that? So it's less than what? Negative 3. Is it or equal to, or is it just less than? It's or equal to because of this bracket right here. And that's it. What do you think? Yeah, It's a good way to start off the new year, right? Easy lesson like that. Sure. So let's give you your homework. I already gave you the paper today, but I'll write it down for those who might be watching online. So this is part 1. Make sure you please put part 1, okay? Don't just put section 1.5. Put section 1.5 part 1, and then you could put the page numbers and all that kind of stuff as well. But in the grade book, I don't put the page numbers in my grade book, okay? I only put section 1.5 part 1. So when I'm putting stuff in the grade book, I'm only looking at that. I'm not looking at what page it is. So it's page 132, and it's 11 to 37, and I'm just giving you the odds, making it super easy for you. So that is your homework right there. Everybody good? Yeah, it should be pretty easy. Good way to start it off. Remember, 2 more assignments to help your grade out. All right, that's all you got. So make sure you do them both. That's it.